Welcome to the next video in our series, which is the cosine rule. Cosine rule as opposed to the sine rule. So note that sine rule has an ambiguous case, but the cosine rule doesn't have an ambiguous case. So it's a bit more straightforward, this one. So the cosine rule, this is what you get in your formula booklet. Looks nice and complicated. So same as before, like the lowercase letters represent lengths and the uppercase letters represent angles. So of course this is a version you use to find a length as opposed to an angle. So again, let's prove. It's always just nice to practice our SOHCAHTOA and Pythagoras and do a bit of a proof first of all. So again, there's many other ways you can prove this formula here, but below is just one of them. So here's your non-right angle triangle again. So we've got angles A, B, and C, and lengths A, B, and C. Well, C's been divided up here. So notice that the bottom length C, this bottom length in red is C, of course. Notice that it can be split into two parts. The shorter segment here we'll call X. So when you kind of you subdivide the non-right angle triangle into two right angle triangles and label it H, but that's been done for you. So when you do that, it splits the bottom length C, which is in red, splits it into X. And if this little length here, we can call this one X. So therefore this other length here, the longer length here, must be C minus X, because C is the whole red length here. And if this one is X, then this length here must be C minus X. Look at the right angle triangle on the left side. That's what we're asked to do first. Look at the right angle triangle on the left side. Use Pythagoras' theorem to write a formula for b squared. So in this right angle triangle, you notice that b is the hypotenuse. So b squared equals x squared plus h squared. Would you agree? It's the sum of the squares of the two legs. So we could write, for example, b squared equals x squared plus h squared. That's just using Pythagoras in this right angle triangle, because b in this case is a hypotenuse. So now you're asked to rearrange this formula so that h squared becomes the subject. So you might not be able to see that on yours. So it says rearrange the formula so that h squared becomes the subject. So to make h squared the subject, we would have to subtract x squared from both sides. So if you subtract x squared from both sides, you end up with h squared here, and then you would get b squared minus x squared on this side. So h squared equals b squared minus x squared. Look at the right angle triangle on the right side. So looking at this right angle triangle on the right side, use Pythagoras' theorem again to write a formula for a squared. So the hypotenuse of this one is a squared. So of course it's going to be the sum of the squares of the legs again. So h squared plus c minus x, all in brackets, squared. So a squared equals h squared, which we've already got, plus the other leg squared. And don't forget you need to write c minus x in brackets, squared. Because if you don't have brackets, then only the x is squared and not the c. Now rewrite the formula above, but replacing h squared. So we're going to replace the h squared with the formula found previously for h squared. So see, h squared equals this. So we can substitute this formula in here for h squared. So that's what we're going to do. We're going to rewrite this line now. A squared equals, instead of h squared, we're going to write b squared minus x squared, which we got from here. So we replace that with that. And don't forget you've still got plus c minus x squared is still there. Next step in our proof, use quadratic foiling. So basically it's quadratic expansion, to expand any parts of the formula above that can be expanded, for example this red part. Remember to then collect any like terms. So what do we mean by this? We mean to write it out with double brackets. So you've still got the green part like before, b squared minus x squared plus c minus x, c minus x. And then we need to do the foiling. So that's what I'm showing my rainbows here to show that I'm going to do some foiling now. So b squared minus x squared plus c minus x, c minus x. Next step, do your foiling. You're probably guessing, so b squared minus x squared is still there. Plus, when you do this first expansion, you get c squared. Do this expansion, you get minus cx. Do that bottom expansion, you get minus xc, which is the same thing as minus cx. Do the last, expand the last, you get positive x squared. Collect any like terms. So this says b squared minus x squared. And when you notice you've got negative x squared here and positive x squared here, so they'll cancel out. So you're just left with b squared, negative x squared's gone because it's been cancelled out by the positive x squared, and you're left with c squared minus cx, which is the same thing as c squared minus 2cx, because we've collected these two like terms. Almost there. Now use the right angled triangle on the left and SOHCAHTOA to make a formula for cos of A. So cos of A, according to SOHCAHTOA, is equal to the adjacent over the hypotenuse. So using the triangle on the left, the adjacent is x and the hypotenuse is b. So we can say cos theta equals x over b. And so rearranging this, so basically rearranging this, I'm not referring to that, I'm saying rearrange this formula to make it x equals. So to make x the subject, we need to multiply both sides by b. Multiplying both sides by b creates b cos A. So x equals b cos A. And now substitute the formula for x. So this is why I've got this arrow now. So we're going to rewrite the cosine rule. This is almost the cosine rule. But instead of the x, we're going to substitute in this value here, b cos of A. Substitute it into there, and now write that out. And you'll get a squared equals b squared plus c squared minus 2c b cos A, which can also be written as, well actually, I'll just write that. So notice we've just written b squared plus c squared minus 2c, but we've replaced the x with b cos of A. Looking at the cosine rule at the top, it's pretty much this, but it's b squared plus c squared minus 2bc cos A, showing you above. B squared plus c squared minus 2bc cos A. So we've just proven this cosine rule using a bit of Pythagoras and a bit of SOHCAHTOA. So now let's go on to applying this cosine rule. But also, just notice that the cosine rule version that you're given in the formula booklet, that is for finding a length A. So obviously to find A, you would work out these values and square root both sides to get A by itself. But what if I'm asked to find an angle, like angle A? What would you do then? So let's do a little exercise in transposition, practicing our transposition from year 9, like basically rearranging formulas. Let's try to rearrange this formula to make A the subject. And we're going to do that step by step. Use your skills in transposition to rearrange the cosine rule to make the angle A the subject. Just so you can see how you can also use this formula to find an angle instead of a length. So what I did first of all, I just rewrote the formula again. Feel free to do that if you like. Just like to have it rewritten down there. So we want to make A the subject. So what might you want to do first? And notice that the term that has A in it is negative. So what I tend to prefer to do, this is one way you could start. You could start by adding this term to both sides so that it's no longer negative. And on the next line, I'll show you what I mean by that. So you could start by adding 2bc cos A to both sides, because that will make the term that has your subject in it a positive. I personally find that very helpful. So in doing that, you would end up with A squared plus 2bc cos A, because we're adding bc cos A to both sides. And when you add it to this side, it cancels out that one. So equals, then you're just left with b squared plus c squared. So a squared plus 2bc cos A equals b squared plus c squared. So what's just nice about that is the term that has your subject in it, A, capital A, angle A, is now positive. I find that way easier to deal with. What would we do next? I would suggest let's get rid of this by cancelling it out by subtracting a squared from both sides. So when you, I'll write that out actually, a little instruction. Now subtract a squared from both sides is what we're going to do on the next line. So when you subtract a squared from this side, the a squared is no longer there, no longer appears. So we just got 2bc cos A equals this side, b squared plus c squared, but remember we've also subtracted a squared to balance it. So subtracted a squared from both sides leaves you with this. What might you do now? We want to make A the subject. So you can't just divide off cos, so that's not, because cos is actually attached to A. So think of this section here, cos and A, they're kind of bound together right now. So eventually we'll inverse cos both sides, but first of all, before you inverse cos from both sides, you really need to divide off 2bc from both sides. So next step now, divide both sides by 2bc. So we're going to divide off this. So we still have cos A, they're kind of bound together. The cos of A is still a unit. So we've got b squared plus c squared minus a squared is still there, and we're going to divide this side by 2bc. So this now has become cos A because we've divided both sides by 2bc, and this side has now become this fraction because that's how we show divide. Very simple last step now. You're almost there. Cos of A, to get A by itself, now you can inverse cos both sides because we've moved everything away. So now we can cos minus 1 both sides, or inverse cos. Take the inverse cos of both sides, same thing. And you'll probably notice that it makes that angle A equals inverse cos of all of this fraction in brackets. There it is. And voila. We have our cosine rule, but rearranged to make the angle A the subject. Most common thing is people will forget to take the inverse cos. They'll work out this fraction and think that's the answer. So you can always look and say, did I get an angle of 9,000 degrees, and for something like that, then if it doesn't make sense, then maybe think, oh, maybe I didn't take the cos of -1 of that, for example. That's just a ridiculous example though. So if you've got a way of remembering it, I tend to remember. Here's the original version of the cosine rule up here. So see, it's b squared plus c squared. I tend to just remember it's cos of -1, still b squared plus c squared at the beginning, and then what's subtracted at the top is -a squared. So you've got the square of all of them. B squared plus c squared is still together, but then it's minus a squared, and 2bc is down here. Notice that the one that appears here has to be the side that's opposite the angle you're looking for. So the length that should appear and get squared here should be the length that's opposite the angle you're looking for. That's very important. And BC and BC are both here. Doesn't matter which one's BC and BC so long as this one is the one opposite the angle you're looking for. Now let's try to apply both versions. This is the angle version, which unfortunately is not in your formula booklet, but the length version is in your formula booklet. You just have to remember to get the length, you then have to square root both sides. So let's try applying this. So now try out your formula. Remember to label your triangles A, B, C, and so on. You can do that if you like. Or just be aware that you need 3 sides and an angle. So remember sine rule? It's when you've got angle, it's opposite side, angle, it's opposite side. You know when you need the cosine rule instead is when you're dealing with 3 sides and an angle in terms of your list. Your list is kind of like what I'm circling here. So find the length of the remaining side. So length we tend to label as x. And notice like what I've done here is I've circled in red my 3 sides. So circle, like label the thing you're looking for to begin with, and then try to work out what you've got. We've got angle opposite side, but we don't have angle opposite side, angle opposite side. So it's not the sine rule, but when we've got dealing with 3 sides and an angle, then it's cosine rule. And it's cosine rule for a length. So 3 sides and an angle means cosine rule. But you have to label the thing you're looking for first, the unknown, before you can decide that. So then x, we're going to use this thingy here, but I tend to, a lot of people will just work out this and forget to square root both sides to get a. So I would strongly suggest go straight to, when you're working at a length, go straight to taking the square root. Here we go. So we're working out this missing length. So it's basically just the sum of the squares of the other 2 sides minus 2 times those 2 sides, subbed in again, 18 and 20. Doesn't matter if you had 20 squared plus 18 squared because you're adding. It doesn't matter about the order. Here it also doesn't matter about the order because you're multiplying them. Cos of 54, so cos of the angle. Of course the angle has to go with the cos. You can pop this straight into the calculator just like that, and I would strongly suggest write this formula out beautifully substituted like this. Don't use multiply signs, use nice brackets for substitutions. And make sure you've got your square root over the whole thing, because the very common thing is people will forget to square root the final answer to get the length. And then plug it into your calculator. To 3 sig figs you should get 17.3, and it's a length and the units are meters. Nice work. So what's important, by the way, is a little thing you might want to note. the side we're looking for must be opposite the angle. So if they gave you another angle, well, for one, you could have used a sine rule instead. But if they gave you another angle, just make sure that the angle you sub into the formula is the angle that's opposite the side you're looking for. Because remember, that's if that's little a, that has to be big A. So little a must be the side opposite angle A. Little thing to note there. Find correct to one decimal place the unknown in this little example. And what did they give us? They gave us, they want us to find theta. I'll call that A. 8 meters. They told us that this was 7 meters and this was 9 meters. So, and theta, so it's 3 sides and an angle. So 3 sides and an angle. I like to circle my angle in a different color. 3 sides and an angle. And just reminding you that in the formula, the angle A, side A has to be the side that's opposite the angle. B and C just can be either of these two, but what's really crucial is, when using the angle version, side A has to be opposite angle A. So this goes in for A. So let's write that, a little note on that. The A must be the side opposite the angle that we're looking for, the angle theta. So let's use the rearranged version. See if you can remember it. It's this one. It's not in your formula booklet, unfortunately, for GCSE. So you have to just remember how to rearrange it. So angle equals cos of -1. And then don't forget, it's the 2 sides squared and added together minus the side opposite the angle squared, the one that the A has to come at the minus part, over 2BC. So 2 times these 2 sides here. And plug it into the calculator, use a trig button to produce cos -1, use a nice fraction button to produce this exactly like this into the calculator. I would strongly suggest don't work out bit by bit, just do that and work out your answer. And it's an angle, so what should we have here? We should have a degree sign. 48.2 degrees. Nice work. And remember, like, you really must show this substitution step. Don't use multiply signs down here, like it just gets messy, it looks like X's. Use brackets for substituting and multiplying. But because these are squared and they're positive numbers, that you didn't need brackets up here. Let's apply this again. So example, find the length BC. So the length version is mega easy. Length BC is down here. You go straight to using the formula that's in the formula booklet. But don't forget, really, really important, you need to square root both sides. So X, I've labelled it X. And we also know it's the cosine rule as opposed to the cosine rule, because once we labelled our unknown, we're dealing with 3 sides and an angle. And the unknown is opposite the angle we're given, so that's important. So X is equal to the square root of the sum of the squares of the other 2 sides, 8.3 squared, so big square root sign, by the way, 8.3 squared plus 5.4 squared minus 2BC, so minus 2 times this times this. Use brackets to show you're substituting and multiplying. Cos of the angle opposite the X. So cos 72. This goes beautifully into your calculator. Use brackets for multiply, that kind of thing. Feel free to pause, try practicing doing this, and see if you get the same answer as me. To 3 sig figs, we should get 8.39. It's a length, and our units are centimeters. And so a little reminder of why we use the cosine rule as opposed to the sine rule. 3 sides and an angle means cosine rule. Whereas remember, sine rule means angle, opposite side, angle, opposite side. That's how you know. Another little example here. So in triangle ABC, so we haven't drawn it for you, AB is 7, BC is 5, and CA is 8. Find the measure of angle BCA. Hint, draw the diagram first and label all sides and angles given. So here's your triangle. So remember the angle, you just have to make sure that its opposite side is correct. So it might help if you kind of label the sides as well. Let's label, sorry, the angles. Let's label the angles in here. BCA, so if it's BCA that we're looking for, meaning theta, that means this is C, because remember the middle letter is where the angle is. So BCA, let's see, CA is 8. So CA is 8, so A must be over here. And let's check this, AB is 7. Yep, so this one's got to be B. AB is 7, and so on. You could have just started off by labeling ABC and putting everything in the right spot after that. That's also okay. It's an angle version, so use your rearranged angle version. Theta equals, so remember you've got to start off with cos minus 1, and then it's b squared plus c squared to start with. So b squared plus c squared, and remember, just kind of ignore like A, B, and C on this. Just remember that the angle, the A, the part that is subtracted here, has to be the side opposite the angle. That's really important. Angle and side are right away from each other in this formula. So ignore my little arrow there, that's about something else you don't need to know. Over 2bc, so 2 times these two numbers squared, so these two numbers appear here. So you've got your thing there. So cos minus 1, plug this into the calculator, 8 squared plus 5 squared minus 7 squared. Use your fraction button to make this, use the trig button to find cos minus 1 on the TI Inspire. Feel free to pause and check your answer. And it turns out you get exactly 60 degrees. So if you want to write 3 sig figs, 60.0 degrees, you can, but you're allowed to just write 60 degrees there. And that's just remembering it's an angle. And of course, oh, sorry, that's the end of the lesson, by the way. And this is the cosine, using the cosine rule as opposed to the sine rule, because when we labeled our unknown, we were dealing with 3 sides and an angle. And the side that goes in here, in the negative side squared, has to be the side that's opposite the angle. And that's the end of the cosine rule video. Thank you.